Okay, so today we are going to talk about how to find a y-intercept. Or no, that's sorry, different class. We're going to talk about inputs and outputs with a graph today. Y-intercept next week. Um, so we talked about evaluating earlier this week. We looked at creating a table of values yesterday, where we were looking at inputs and outputs. You need notes, yeah. Okay. So we were talking about all this stuff yesterday and the day before with functions, and then we looked at tables yesterday. So today we're going to do a lot of the same things. We're going to see function notation again, but with a graph this time, okay, with a graph. So this should look familiar from Algebra 1. We did the same type of stuff in Algebra 1 with a lot of linear functions. We're going to build in some other types of functions today. So remember, when we've got this function notation here, f of 0, that means that we know the x value. And what we're looking to find is the y value. Okay. So for our questions here, for example, 1, we're using this graph off to the side. When our x value is 0, so x is 0, on the graph, we're at the point 0, 3. Thank you. Okay. So my y value then is 3. Does that make sense? We did this with tables yesterday, right? If I flip back for just a second, we talked about what's f of 2, right? And so we said, look in your table, when x is 2, y is 12. Same idea, but this time with the graph. B, f of 4 means we're going to 4 on the x-axis, follow that to the point on my graph, and that y value is 1. This is the point 4, 1, f of 4 equals 1. That makes sense? Okay. C, f of negative 2. So I go to negative 2, where x is negative 2. I follow that to the point on my graph, and that y value is 4. Raise your hand if this looks familiar to you. Yeah, we did this last year. It should. For D, D, E, and F, this sort of bottom chunk of problems, we're going the other way. This time I'm giving you the output and I'm asking you to tell me what input matches. So negative 4 is my y value. I'm going to go down to negative 4. And, well, this is a line. So I know it should keep going, and I should have an output value down here, back this way somewhere. But can I see it on my graph? No. So I'm just going to write, can't see here. The limitation of representing a function with a graph or with a table is I am selecting values to show you. When I have a function, I'm describing every value. Okay, but when I've got a graph, I'm showing you just a little like snapshot. When I'm giving you a table, I'm giving you again a snapshot. Okay. For E, f of something equals 2. So I'm going to 2 on the y this time because I know the output, I know the y value, and I'll follow that to the graph and tell you the x. So when y is 2, x is 2. And then for f here, f of something equals 3. So when my y value is 3, here's that point, my x value is 0. Questions for me so far? Okay. When we're looking at a line as our graph, this is going to be super cut and dry, right? Because for a line, one x matches with one y, and each y only matches with one x, right? It's 1 to 1. Where this gets maybe a little trickier is when we have functions that are not lines, when our graph's got some maybe curves to it. So same idea for example 2, but I want you to remember that if I've got more than one value, I need to report them all, okay? So for A, f of 1 when x is 1, y is also 1. F of -4, so when x is -4, follow that to my graph, and my y is -4. C, f of 0, so when x is 0, that's right here, my y is also 0. Anytime you're looking at a function, this should be the case where if I give you the input, there is only one output. But for our later section here, we can have times where an output can come from more than one input. So we're going to see that here in just a second. So for D, f of something equals 5. So here's 5, just one spot on my graph. So x had to be 2. If my output was 5, my input had to be 2. For E, my output is 1. My y is 1. I've got more than one thing here, okay? So I need to report it all. In this case, we have 2 inputs, -2 and 1. I put a comma between mine. If you want to write and in between yours, that's fine too. If I had 3 places, I'd report all 3. If I had 7 places, I'd report all 7 of those inputs. And then f of something equals 0. So here's 0 on the y. We've got a point right here, but we also have a point back here that has an output of 0. So again, I need to report both. So this would be -3 and 0. With me so far? Okay. So then the last set of problems that we're going to take a look at for today, we're going to kind of bring together everything we've looked at for the last couple of days. So today, our focus, our new thing that we looked at was inputs and outputs with a graph. We looked at tables, we looked at functions. So on the next page, on page 7, we've got 3 different functions here, each represented in a different way. F of x is a function, g of x we've got as a table, h of x we've got as a graph. And we're going to look at the same thing with all of our different representations here. So tying everything together, okay? We're going to talk about a couple of these together. So A, G of 2, couple things to watch out for here. 1, make sure you're paying attention to what function you are talking about. So this says G of 2, so I need to make sure I use G of x, my table here. And then 2, pay attention to whether you have the input or the output. So G of 2 means I know the x value. So for my G of x, I know the input is 2. When the input is 2, my output is 0. And then let's also look at D together. So for D, f of x, and my output is 8. F of x was our function, 1/2 x plus 4. And I'm telling you the output is 8. Your job is to find the input, okay? So when I've got that function, remember we're going to have to do some algebraic manipulation there. Thank you. So I get 1/2 x equals 4. Multiply by 2 on both sides, get rid of the 1/2, and our input there was 8. I would like you now to try the rest of example 3. Try the rest of example 3. Okay, let's talk about these. F of -4. We're using our function, our f of x here. This is an x value, so we are plugging in and evaluating. Oops, should probably put it into the 4 there. There we go, +4. So this would be half of -4 is -2 +4. We would get 2 here. F of -4 is 2. Please check your work as we go. For C, h of what equals -2? H is our graph. -2 would be our output, our y value. This time I've got 1, 2, 3 different inputs that could have matched that output. For some of them, we've got to estimate here. That's okay. Okay. So this guy, I'm going to say negative maybe 0.75-ish. Looks like it's past a half, but it's definitely not to 1 yet. So I'm going to say negative 0.75. This would be 1. And then this guy here, and maybe 2.75-ish, somewhere in that neighborhood. We're approximating, so if you don't have exactly what I have, that's okay. For E, g of what equals 0? So g of x is our table, and we know the output is 0. The input would be 2. And then fh of 0 equals, so h is our graph. My x value, my input is 0. The input is 0. My output is 0. Not too bad? Okay. Last thing in our packet for today, using the same functions, f of x, g of x, and h of x at the top, I want you to compare the function values you would get from here. So here's what I mean by that. I've got g of 2 and h of 2. And you're going to fill in that blank with one of these symbols, okay? G of 2 is 0. H of 2 is -4. We are going to compare those values. 0 is greater than -4. So I fill in that 0 is greater than -4. Does that make sense? Function values, not the inputs, but what are the outputs? I want you to compare. So I want you to finish example 4 for me. Once you've done those 3 remaining problems, I want you to check your answer with someone near you. Okay, check your work with someone near you. If you have different things in those blanks, I want you to talk about what function values you got. So you can make sure everybody's looking at the correct function and that you're finding those correct outputs.